The manufacturing process of a bulldozer is a complex engineering task that combines the durability of metal and precise control technology. The following are the main steps of the production chain. Design and engineering. Before proceeding to installation, engineers use computer-aided design software to calculate the compressive forces and weight balance. Excavators require high thrust, so all parts must be designed to withstand high pressure. Producing components for heavy machinery, such as the base or the blade of a bulldozer, from forged steel, is an engineering process that requires the utmost care to ensure that each component can withstand the enormous stresses. The following is the process of forging and shaping the steel into shape. Number 2. Chassis and frame fabrication. Metal cutting. Uses large-scale plasma or laser cutting machines to cut thick steel sheets. Welding. The main frame is welded using robots to ensure 100% strength and no gaps that can cause breakage during heavy work. The undercarriage is the most important and expensive part of a bulldozer because it is subjected to the most stress and wear when working on rocky or muddy ground. The following are the main components that make up the undercarriage system. Track chain or track link. It is a set of metal wheels connected together in a long chain. The chain acts as a track for the other wheels to walk on. It is made of high-strength steel to resist traction and wear. Track shoes. It is a metal shoe attached to the track chain that makes direct contact with the ground. It has teeth or grousers to help the machine grip the ground well and not slip easily when pushing heavy soil. Drive sprocket. A metal wheel with large teeth that is connected to the travel motor, final drive. It will rotate to pull the chain forward or backward. The sprocket teeth are specially designed to be extremely strong so that they do not wear out quickly. Track rollers and carrier rollers. Track rollers. These are the wheels at the bottom that support the entire weight of the machine and help the chain run straight. Carrier rollers. These are the small wheels at the top that prevent the chain from sagging. Idler. Located at the very front of the lower unit, it is responsible for orienting the chain and works with the track adjuster to adjust the tension or slack of the chain. Track frame is the largest and strongest steel frame that holds all of the above components together. It is designed to withstand heavy bending and impact. Maintenance and production. Since the lower parts cost about 20% to 30% of the total cost of the machine, the metalworking process for these parts uses induction heating to make the outer surface extremely hard to prevent wear, but the inside remains soft to prevent breakage. Installing the engine into a bulldozer is the most important stage because it connects the heart to the body of the machine. The engines used in bulldozers are mostly large-scale diesel engines with high power and heavy weight. The following are the types of engines and the installation process. 1. Features of bulldozer engines. These engines are not like ordinary car engines. They are designed for high torque to push tons of soil or rocks without stopping. Large-scale cooling system to work 24 hours a day under the hot sun. And durability. The internal parts are made of the highest quality steel to withstand heat and pressure. 2. Pre-installation preparation stage. Before installing the engine, the engineer must connect the transmission system. Most of the time, the engine is connected to the torque converter first so that it becomes a single unit. Check engine mounts. Place special rubber mounts where the engine is to be mounted to prevent vibration from the engine from damaging the machine frame. 3. Installation process. 1. Hoisting. A large crane is used to lift the engine with great balance. Some bulldozers can weigh several tons, so maintaining balance is important. 2. Alignment. This is the most difficult part. Engineers need to align the engine with the mounts and the rear wheel drive system. 3. Bolting. Once in position, high tensile bolts are used to secure the engine to the frame. 4. Connections. Fuel system, connect the diesel pipes. Cooling system, connect the water pipes to the giant radiator at the front. Electrical system, connect the control wires and sensors to the computer in the cabin. And air system, connect the turbocharger and the exhaust pipes. 5. Post-installation test. After installation, it is not yet used immediately. 1. First ignition, to listen to the sound and check for oil or water leaks. 2. Pressure measurement, check the engine oil pressure and hydraulic system. 3. Speed measurement, ensure that it is operating according to technical standards. The cab of a bulldozer is not just a place to sit and operate, but a control center that is specially designed to provide the highest safety and comfort to the operator, even in dusty, vibration-filled, and hazardous work environments. Here are the main features of a modern bulldozer cab. 1. Safety structure. This is the most important feature, which is made of high-quality steel. ROPS. Rollover protective structure, a steel frame that protects the operator from injury when the machine overturns. FOPS, falling object protective structure, a sturdy roof that prevents heavy objects such as rocks or trees from falling from the cab. 2. Noise and vibration reduction technology. Because the engine and its undercarriage produce a lot of noise. Double glazed windows. Helps block outside noise. Hydraulic mount. The entire cabin is mounted on a pump system that helps absorb vibrations from the machine body, making the driver less tired. 3. Control systems. In modern cabins, long levers are no longer used as before. Joysticks. Use 2 small control levers, left, right. One for controlling the direction of travel, and the other for controlling the blade. Touchscreen, for monitoring engine temperature, oil pressure, and GPS to view the terrain. 4. Comfort and working environment. Pressurized cabin. The cabin is closed and has a slight air pressure to prevent dust from flowing inside. Air conditioning and electric seat. The seat can be adjusted according to the driver's body weight and has an air pump system to help sit for long periods without back pain. 5. Visibility. 360-degree all-around mirror, designed with a curved shape to give the operator a clear view of the front and rear of the blade. Auxiliary camera, equipped with rear and side cameras, displayed on the in-cab screen to avoid collisions. Additional information for content, YouTube Insight. If you produce a video about the cab, showing the view from inside the cab while working, POV view, is what viewers love the most because it provides a unique experience and shows the state-of-the-art control technology.